Hi everyone, I'm Cheryl. In this problem, we're asked to find the curvature of my space curve cosine 1/2 s times vector I plus square root of 3 over 2 s vector j plus sine of 1/2 s vector k. Now it's worth noting here in this problem, the parameter s is the arc length parameter. That's going to be helpful because when I find the curvature and I'm using arc length parameter, all I need to do is find the norm of the derivative of the unit tangent vector. All right, so in order to get this information, we need to do a little side work. So first of all, let's figure out what that unit tangent vector is going to be. So the unit tangent vector is r prime of s divided by the norm of r prime of s. Okay, so for this problem, we need to take the derivative of my position function. So the derivative of cosine is minus sine, so I'll have the minus sine of 1/2 s. Again, don't forget to multiply by 1/2 by the chain rule times vector I. Now I'll take the derivative of square root of 3 over 2 times s, which is just root 3 over 2. And that's times my vector j. And the derivative of sine is cosine, but again, by the chain rule, I'll have 1/2 cosine of 1/2 s times vector k. And that's all over the norm. So the norm, remember, is going to be the square root of the squares of, or the sum of the squares of each of those components. So when I take this piece and square it, I'm going to get 1/4 sine squared of 1/2 s. When I square this component, I'm going to get 3/4. And when I square this component, I'll get 1/4 cosine squared of 1/2 s. Okay, now, if you take a look at the denominator, notice that I'm going to have a 1/4 sine squared of 1/2 s and 1/4 cosine squared of 1/2 s, that first and third term. I can factor a 1/4 out, and when I do that, I'm left with 1/4 times the quantity, sine squared plus cosine squared, which is just 1. So the whole thing can be reduced to minus 1/2 sine of 1/2 s times my vector I, plus square root of 3 all over 2 times my vector j, plus 1/2 cosine of 1/2 s times my vector k, all over the square root, of 1/4 plus 3/4. 1/4 plus 3/4 is just 1. So that whole denominator turns into the square root of 1, which is just 1. So again, the whole thing reduces to minus 1/2 sine of 1/2 s times vector I plus root 3 all over 2 times vector j plus 1/2 cosine of 1/2 s times vector k. Okay, now as a shortcut, you might want to notice that if you are using the arc length parameter, the norm of r prime of s will always be equal to 1. So it's not surprising that the denominator turned into a 1 for me. Okay, so that is the unit tangent vector. Notice in my formula, what I really need is the derivative of that. So let's go ahead and take the derivative of that function. The derivative is going to be a minus 1/2 times the cosine of 1/2 s times 1/2. So that's going to leave me with a negative 1/4 cosine of 1/2 s times my vector I. The derivative of square root of 3 over 2j, that's just 0j. And for the next piece, I'm going to have 1/2 times minus the sine of 1/2 s times 1/2. So that's going to give me a negative 1/4 sine of 1/2 s times my vector k. All right, so that was all the side work. Now I'm ready to actually get the curvature. The curvature is going to be the norm of that derivative that I just calculated. So I'm going to have the square root of each of these pieces squared. So I'm going to end up with 1/16 cosine squared of 1/2 s plus 0 squared plus 1/16 because I'm going to square it, sine squared of 1/2 s. Okay. Notice I can factor out a 1/16, and I'm left with cosine squared of 1/2 s plus sine squared of 1/2 s. All of this, the cosine squared 1/2 s plus sine squared 1/2 s, all equals 1. So I'm reduced down to the square root of 1/16, and I have a curvature of 1/4. I hope that was helpful. Thanks.